number 10. There's a circle equation given to us in this form. And from this form, we know how to find the center of the circle. Let's do that. Divide this with -2. That gives us a 3, comma. Divide this with -2. We get a -2. This is the center of the circle, 3, comma, -2. We can also find the radius here, and we will probably need the radius somewhere in the question. To find the radius, you square this 3 squared, plus, then you square this -2 whole squared, minus the constant here, which is -27. So all of this simplified becomes square root of 40. So the radius of the circle is square root of 40. Okay. Then we're told that at P, there's a tangent to the circle and the coordinates of P are 5, 4. The tangent to the circle at P meets the x-axis at A. If A is on the x-axis, that means its y coordinate is 0. So its coordinates would be some x, y. And similarly, since B is on the y-axis, its x is going to be 0. So it's going to be 0, y. And we have to find the area of OAB. So we need area of this triangle. So all we need is this value of x and this value of y. Then we'll be able to use half times base times height to get this area. Okay, now how do we get these x and y? We will first need equation of the tangent. And for A, we'll make its y 0, and for B, we'll make its x 0. Okay, now how to find equation of the tangent? We know that the radius and the tangent, they are perpendicular to each other. Find the gradient of, let's call this center C. Let's find gradient of CP. It's going to be y2 minus y1 over x2 minus x1. So that's 6 over 2, which is 3. That means gradient of the tangent is going to be -1 over 3. So y equals mx plus c. To find c, we're going to use the point 5, 4. Substitute that. And when you do that, you will get y equals -1 by 3 x plus 17 over 3. You can do the working on your own. Okay. Now, to find the coordinates of B, B is just the y-intercept, make x 0. This becomes 0, and y is 17 by 3. Also, C in y is equals to mx plus c is the y-intercept. So this would be 17 by 3. So 0, 17 by 3. And for A, make y 0. So this becomes 0. Then 17 over 3 comes to the other side. Becomes -17 over 3. Negative cancels. 3 cancels. So we're left with 7. So, sorry, 17. So the coordinates of A are 17, 0. Okay. So now we know that this length is 17 by 3 and this horizontal length is just 17. So half times base times height gives us 289 upon 6. Okay. Part B. Point Q and R lie on the circle such that PQR is an isosceles triangle, is an equilateral triangle, sorry, find the exact area of this triangle. Okay, so if it's an equilateral triangle, let me just get rid of the other working. Okay, so if this is an equilateral triangle, and we have a center of the circle in the middle, then these 3 would make 3 equal triangles. And what would be this angle? It would be 360 divided by 3, so 120. This triangle is this angle is 120, this angle is 120. and this angle is also 120. So we have three 120-degree angles in the figure. So figure is somewhat like this. So each of this angle is 120. And also the three inner lines, this one, and this one, they're all the radius of the circle. So under root 40. So this is under root 40. And this is under root 40. Also, this is under root 40. Now do what? Find area of one of these triangle and times it with 3. So I'm doing 3 times half times, I'm using the O-levels formula, half AB sine C. If you have an angle C and a length A and a length B given to you, two lengths and an included angle, then to find the area, you use this formula. Okay, so half times under root 40 times under root 40 times sine 120. And the question says, give the exact answer. That means you're not allowed to press SD in the end. So it's going to be 3 times half times under root 40 makes 40, by the way. So it's going to be 40. And sine 120 is, insert form, square root of 3 upon 2. Simplify this, you will get 30 under root 3.